Hello everyone. So I wanted to continue my projective geometry series here, involving division by zero. But in this video I simply wanted to describe some of the starting definitions and some of the more fundamental theorems about projective geometry. So it helps to consider, at first, these definitions, which are elementary correspondences, perspectivities, and projectivities. Now these are really the three most basic kinds of definitions, and kind of the three most basic relationships of projective geometry, at least as I see it. I'm not completely qualified to give too many of my own insights. However, I have gotten information from a few very good sources, very reliable sources, which I'll tell you about in the description, but this is taken from the University of Minnesota, I'm fairly sure. They have quite a good course on this, actually. Moving on with this content here. Whenever you see the phrase pencil of points, basically what that means is essentially the set of points that form a line. And when it says pencil of lines, we can consider that to be basically one single point, and we can consider all of the possible lines that run through that point, or I guess we might say is incident with that point. That's what a pencil of line is. Pencil of lines is basically this whole family of lines which share the property that they run through the same point. This arbitrary point, which we know. And so the first thing you should pay attention to, the first thing you should mind, is an elementary correspondence. And so we see actually a very good image of this, or we're about to see some very good images of this that illustrate these definitions. But you can read it right here, and it says, you know, we need to ensure that each point of the pencil of lines is incident with, or, you know, intersects the corresponding line of the pencil of lines. So basically what it's saying here is that we have one line, a single line, and a point not on the line. Then basically, if there's a kind of mapping, an isomorphic kind of mapping between each line and each line through the point and each point on the given line, then that is an elementary correspondence. The best way to see that is really through this third image right here, actually. Basically, this is the elementary correspondence. This is an example of the elementary correspondence, because basically every line, in this case, you know, we have lowercase a, lowercase b, lowercase c, and all of these, you can think of them as originating from this one point, or our given point, and we also simultaneously have this given line. And as I was saying, every one of these lines intersects the given line at, you know, one and only one point. So it's an elementary correspondence. Now we also have something called a perspectivity, and going back to our definitions, this can technically be either between two lines or 2 points. We can consider perspectivities, and there are a few different kinds of definitions you'll see for them, actually. But from this source we have, now it really helps to see examples of these, but if the lines incident with corresponding points of the two pencils are concurrent. For this first definition, we're presuming that we have two different lines, and we are kind of defining a mapping, or some sort of, you know, transformation, some kind of function, so to speak, of the points of one line to the points to the other line, basically. So it's a one-to-one correspondence. And we're making sure that basically the lines connecting two corresponding points all meet at one point, basically, and that central point is really called the center of the perspectivity. So I know that's a lot to process at once, so it helps to see them in an image, which thankfully this source does provide. We have one line here, P, I guess it's called, and then we also have P prime, a second line. So there are two different lines, and we have arbitrary points on the line, so we can illustrate that one of them's A, one of them's capital B, one of them's capital C, and then on the other line we have A prime, B prime, and C prime. And so these are the lines connecting corresponding points. You can see right here. And all of those kind of secondary lines, which connect corresponding points, they all meet at the center O. And that is indeed intuitively called the center of the perspectivity. This is a perspectivity. Now, furthermore, we have this third definition listed, is that we have a perspectivity between two pencils of lines. Now, when you hear pencils of lines, what we're really talking about is that we have two different points, and we're considering the lines that pass through each of those points. So, again, bear with me, we're going to see an image of this as well, but we need to make sure that the points of intersection of the corresponding lines of the two pencils, or of the 2 points, are collinear. So this is, kind of a mouthful, perhaps, to define. But basically, in this case, we're starting with 2 points, or, pencils of lines, really they're points, and we're forming a perspectivity such that what is created, or, what we end up with, what is outputted, is a line, actually, called the axis of the perspectivity. And how we get that line is, again, seen very well in this image. In this case, we start with the 2 points, P and P prime. You may be noticing the pattern here that lines are denoted with lowercase letters, whereas points are almost always capital letters. So we have a line A going through this first point, and A prime going through this second point. They meet at some point. The corresponding lines B and B prime passing through these 2 alternate points, they also meet at a certain point, and C and C prime also meet somewhere. And if those 3 points of intersection are collinear, by themselves collinear, and there's one and only one line through them, then the whole mapping, the whole system, is a perspectivity. And the axis of perspectivity is, in this case, the lowercase o, which is this line. So those are the more basic definitions, actually. And then we get to something called a projective. And this is getting, as you might imagine, progressively more advanced. Oh, and also, there are different ways of denoting these things, which I would like to make clear. This is just the difference in notation. For an elementary correspondence, it's this kind of thing. Perspectivity, we have, an arrow, a line, and then usually this O is just the name of either the axis or the center of the perspectivity. And then for projectivity, we can simply have this kind of caret kind of symbol, which you'll see actually for many different uses in mathematics, but in this case, it's simply a projectivity. Now, speaking of projectivities, I need to give you the formal definition, which you can see right here. So basically, it's another kind of one-to-one mapping, as I'm sure you would expect. And in this case, this particular website defines it to be between 2 pencils of points, so it's between 2 lines, typically. You can see that it is a composition of, and I'm going to highlight this, actually. This is really important. And so to put this in the form of a diagram, composition of a finite number of elementary correspondences and perspectivities. The projectivity is kind of like our top layer, at least, of the definition so far, where basically it could be an elementary correspondence, which is that kind of most basic definition between a line and a point, or it could be actually a perspectivity, which can be either, between 2 lines or really between 2 points. We can consider a perspectivity. Or we have this third case, which is basically what we call composition in mathematics. So it can be, in some sense, a combination of these former 2 types. This is really a very special case, a very unique case, if we have some kind of perspectivity composed with an elementary correspondence, or like it's combined with an elementary correspondence, and we get these very unique structures and patterns, which is what we'll get into next. But these definitions help us very much in projective geometry. First of all, just because they're fun, and second of all, because there are theorems, and actual theorems and wonderful ideas based upon these definitions. And plus we get this really cool notation as well up here. And this people don't really talk about this very much, but it's really interesting. I feel like this should be shared or presented more often. It shouldn't be just some obscure, kicked under the rug kind of topic. No, this is amazing. This, people could talk about it and teach each other about it in everyday life, or try to prove theorems about it, try to do research on it. It's interesting and enjoyable. So we'll continue with those theorems coming up next.